So I want to spend a few minutes talking just about some of the questions people have about environmental safety of forest herbicides, and just going to go through this pretty quickly. And actually, this will be posted, so you can look at it a little more closely. But these are some of the questions I think people have. So talk a little bit about the use of forest herbicides, potential effects on environment and humans, how to attain the benefits of forest herbicides and minimize the potential, and ensure that forest applicators are using chemicals safely and effectively. So, that's in fact minimizing your exposure, using the proper equipment. So whenever using herbicides, what's the main thing you always have to remember? Read the label, right? Everything you need to know is on that label in terms of what you need to, what its impact is, what's effective on, as well as safety equipment to minimize exposure. So, question here: can a pesticide be applied to a site that is not listed on the label? No. Can only be applied to labeled sites, okay, which makes sense, all right? But how about, can a pesticide be applied to control a pest not specified on the label? And the answer to that is yes, provided it's found on a labeled site. An example might be, we have a list of species that might be listed on a label on a particular site, but it can't list every species, for example. But as long as that species is on that site, then you can use that to apply that. Make sense? Okay. Can a pesticide be applied at a higher rate than labeled? Okay, no. All right. But it can be applied at a lower rate, obviously. Okay. Labeled application methods. Can any method of application be used? Okay. As long as it's not prohibited on the label. Okay. So it may not mention it specifically, but as long as it's not specifically prohibited, you can still use that application method. So that's a good thing to remember. All right. In vegetation control, forest herbicides, they are very effective. There's no question that in trying to use them, they're based on recommendations. Effective because there's been a lot of research in terms of what level of what amount of materials need to control certain species and so on and so forth. Are they economical? I would say yes. In terms of cost effective. Trying to go out there, and I know there's been a lot of efforts in terms of mechanical control of weeds, for example, and that can be a very onerous and not a very effective task in some cases. And so they can be very economical, as you've seen with the different application methods. You can cover a lot of area and have a lot of impact on habitat. And what about risk? I mean, this is a big issue that a lot of people are concerned about, the risk of using herbicide. But I think you have to think about is, what is the alternative way of controlling a lot of these things? If you're not going to use herbicides, you're going to use some other means, which is usually what? Fire. Okay, well, might be animals, but typically it's going to be some type of mechanical control. So you have to ask yourselves, are there risks involved with putting people out there with axes and hatchets and chainsaws to control invasive species? And there absolutely is. So you have to think about risk in terms of what are the alternative means of controlling invasives or whatever you want to control. And there are risks that are associated with that. And is it necessary? Well, we use the example of tree of heaven, right? So is that a species that can be controlled, mechanically? No. Is it necessary to use chemicals to control tree of heaven? Yeah, it is. Otherwise, you're better off leaving it alone, probably, because you just, as they say, you'll make it mad, right? So you don't want that. So those are just a couple of things to think about. And in terms of forest herbicide usage, now you saw Brett's presentation. In Pennsylvania, they do a lot more treatment than in Maryland because they have a lot more some different issues and a little different system. But in terms of estimated acres in Maryland, you have to kind of contrast this to you can contrast it to agriculture, for example. And I'll just take Carroll County, for example. Carroll County has 62,000 acres of land that is basically treated, with herbicides for corn, wheat, soybeans, vegetations, and others. I don't know exactly how much is treated for forestry, but I'm willing to bet it's a relatively low number compared to that. Now, of course, forest ecosystems are very different than agriculture. There's ecosystem and diversity issues and things like that. But again, relatively, we're talking about a relatively lower number of acres in terms of impact. And the application rates, most forestry applications that we're talking about, 1 ounce to 2 quarts per acre, maybe one time or a couple times per rotation of 80 years. We're doing it to accomplish a certain thing, for example, to secure regeneration, to get rid of invasive species. We have a specific purpose in mind. Not in there every year, using herbicides in forest stands. That's just really not done. So again, in terms of, the actual usage of forest herbicides, it pales in comparison to agriculture, and overall it's relatively minor, I guess I would say. So they're applied infrequently in relatively small amounts. Now, so what's wrong with this person's personal equipment here? Okay, what's the minimum requirements for applying herbicide? Okay, and typically gloves as well. Okay.
Mask is not required on any of the herbicides we'll be using today,
right.
Or any that I saw for forestry.
Yeah, and I'll mention that at the end that they're all general.
Use mist blowers, backpack mist blowers. They choose to wear a mask because you have those fine micron droplets. That is not a requirement of the label.
Nonetheless, we have nothing.
What's that?
Nonetheless, we have nothing.
No, that's important. And the way you reduce, impact of any potential impact of herbicide is by, reducing your exposure. And that's why the label, you read the label, it will tell you exactly what's required in terms of what you're supposed to wear for an acceptable level of exposure. Different application methods, and Brett and Todd just went over a number of these things. Again, another person. Who was that guy anyway? I think that's me. No long sleeve shirt, right? So, so in terms of toxicity, it's a measure of a pesticide's capacity to cause illness or injury, and it's dependent upon the properties of the chemical and, again, the level of exposure. So exposure can be any number of ways. Ingesting it, in other words, you're absorbing it, you're drinking it. You can inhale it. It can be on the skin, or it can be through eye, through eye contact. Acute toxicity is really the one that's primarily measured, and that's the ability to cause illness or injury within a short period of time, 48 hours after exposure. And chronic toxicity is illness from repeated exposure, maybe a long time, obviously. We hear about a number of things, people that worked with asbestos and so on, but this is a much more difficult thing to measure, although for the class of herbicides we're using, there seems to be minimal impacts in terms of any chronic effects. And of course, the way you reduce any potential for chronic effects, as you do for acute effects, is what do? You reduce your level of exposure, right? And you use the proper amounts, and you follow the label. Okay. Acute toxicity is expressed as LD50, or the LD lethal dose that would kill 50% of a test population of animals under a standard set of conditions. And it's the milligrams of pesticide per kilogram of body weight, or by volume by air. Okay, you've heard that term LD50. Okay, and this is the basis for assigning the signal word, whether it has caution or danger, which has certain implications for how it's used, and we'll get into that in a minute. So, right here, caution is the lowest level. And that's what basically all the herbicides that we're talking about, forest herbicides, are caution. They're very slightly toxic or practically non-toxic. LD50 is greater than 500 milligrams per kilogram that would have to be ingested. In fact, you'll see from the chart I have, it's more like 5,000. So, and similar to things like aspirin, stuff like that. So, so this signal word is important. It's an indication of its acute toxicity, as you can see as you get higher and higher. And remember, we'll get into this in just a minute, but most of these are acting on plants and not on animal systems. Pesticides is the big word, right? Then you have herbicides that work on plants, and then you have insecticides on insects, and fungicides. Those are all different classes of pesticides, but forest herbicides, basically are just acting on plants, and we don't have those types of systems that they act on, and I'll mention that in a few minutes. So, the signal word provides information on the likelihood of acute effects only, and it's an indicator of whether the product might cause long-term effects. Well, it's right there already. So your level of risk is based on a combination of the product's ability to cause acute or chronic effects and your level of exposure. Chronic toxicity is over long term, in these types of things that occur, and it's frankly much more difficult to assess. They do some experiments with mice exposed to small doses over a 2-year period, and they divide that by a factor of 10 to 100 in terms of the actual dose or the actual use of the pesticide in general that would cause that impact. So they actually water that down even more so than they find from experiments. Now this is over a 2-year period. So there's a lot of leeway built in there by a factor of a 10 to 100 to reduce that exposure to the user. So, but again, chronic toxicity is a more difficult thing to assess, but there seems to be little impacts with these class of herbicides that we're talking about today. Just to give you an idea, the relative toxicity of common herbicides are right here. Remember that LD50? Okay, it's greater than 5,000. So, very, very low toxicity. They all have caution words. These are the ones you're talking about. Accord is glyphosate. Has a caution word. That's the lowest, danger, the lowest level of toxicity there is. Garlon, we've talked about. It's a little bit higher, but still very low. Oust, and so on and so forth. These are, with a lot of landowners, I think that I work with. I think, in most cases, triclopyr and glyphosate are the two chemicals, or Oust and Oust are probably the 3 chemicals that most people could use to solve most of their problems. And you can see these are relatively low toxicity. Again, this was just this is for dermal and oral as well, and you can see the amount of material to kill a person when you get down to a caution, greater than a pint. So that means you would have to drink a pint of glyphosate, which is a lot. Okay. And then just a kind of a comparison to the oral toxicity of other types of things you see here, comparing them to some common herbicides. You can get into caffeine and aspirin. Aspirin can be fairly toxic, right? So again, just making the point that these are relatively have low toxicity materials that we're dealing with. So the message here is that forest labeled herbicides are low in acute toxicity. Chronic toxicity is hard to measure, and it's measured a little bit differently. So the question is, how can products with such a low acute toxicity be so effective at killing plants? And the reason really is that they work on biochemical pathways that we don't have. Most of your insecticides and other things, work on the nervous system and synapses and stuff like this. That's not the case with the pesticides or the herbicides that we're working with here. Many of them basically just inhibit or upset, growth processes, amino acid production and stuff that affects growth in plants and stuff like that, in systems that we don't have in our bodies. So it mentions here, this is for glyphosate. It inhibits the production of a synthesis for amino acids and things like that. So, and this is just an example of some of the modes of action of some common forest herbicides. And so the point is that we're kind of operating in different systems, unless, of course, you're ingesting very large amounts where you're going to have some level of impact. So the people who register pesticides, or in general, develop pesticides based on their mode of action against the pest. And there can be side effects for some of these, but for most of the ones we have, that's not really an issue. So consider the signal word. The greater risk arises when handling concentrates and mixing and loading, and that's why personal protective equipment is most important when you're dealing with these materials. The same way you would use something you're getting some hot out of the oven. You wouldn't use it with your bare hands. You take some common risks. So all forest herbicides require long sleeve shirts, long pants, shoes plus socks. So you shouldn't be out, spraying herbicides in your shorts and your sandals. Okay. Additional requirements that may be on the label: chemical resistant gloves, eyewear, as well as coveralls or actually chemical resistant suits and things like that for more toxic materials, which we don't really deal with. Every pesticide is classified by EP as general or restricted use. General use means that the homeowner or on our own property does not require certification. And that's why for those of you who own your own property, you can use pesticides on your own property without a certification, as long as it's a general use pesticide. All right. But however, if you're doing it for hire on someone else's property, then obviously you have to have a pesticide certification. And it's required for all government agencies. The other type of material is restricted use, and could cause harm to wildlife, humans, or even when used according to label instructions. And these are materials that people, obviously have a commercial license for, and there's different categories for forestry and so on and so forth. Restricted use pesticide for retail sales to and use only by certified applicators or persons under their direct supervision. Okay.
Can I ask you a question?
Yeah.
What about a scenario like mine where I work for a nature sanctuary, so I own property, but I'm an employee of the organization that owns the property. Do you know?
I think you would still have. You would still have to have. You would have to have the certification, but I think people could work under you. Isn't that correct?
Yep.
Yeah, that's the way it works. Yeah, as long as you're a registered applicator. But that's for sure.
To have a general, but to use a general use.
Yeah, even so, because it's not your property.
Well, yeah, technically you're still for hire.
Okay, you're still for hire, right? But the people that worked under her would not necessarily have to be
Yeah, as long as
had a certification as long as you
I
did.
don't have anybody who works under me, so that's
Okay. Well, if someone did, they would be covered.
I wish I did, but
Okay.
The only times you can get away without a license is regardless of general or restricted based on personal property.
thank you.
Yeah. Okay. So virtually all our vegetation control needs are accomplished through general use herbicides. I think the only one is picklerum is one of the few that's restricted use, isn't it, Todd?
It is put
And-
on K as in put on 101.
And that's really not a herbicide that most homeowners should really be working with because it moves in the soil, it leaches.
There's a tort on RTU, which
Yeah.
some may be familiar with, is not, because the pickleram level in it is so low, it's 5%.
Mm.
So that one, a lot of people would use probably for stump treating.
Mm-hmm.
It's a good product.
It is a good product.
Just don't put too much of it under a tulip poplar tree. We'll
Yeah.
see what happens.
Yeah. In terms of bioaccumulation in the food chain, for silviculture herbicides, most don't remain in the body. They don't show a tendency to accumulate in the food chain. But they are used a lot for habitat modification. So when he talks about effects on wildlife, basically there's not a real effects on wildlife. I mean, there's numbers in terms of how much a deer would have to eat to, it's just astronomical. And it's really not there. The literature shows that. But really the real value, the effect on wildlife of herbicides is the ability to manipulate habitat. That's what we're basically doing here. When you're removing understory, you're removing certain trees, you're favoring certain trees, you're basically altering wildlife habitat. And that's probably one of the greatest values of using forest herbicides. You can be effective over a larger area. Yeah.
So when you're talking about the animals, you're not talking like how do it affect pollinators?
Maybe you could answer that.
This is a very good topic, actually.
Yeah, it is.
Most of my business is utility right away. We sell every ounce of chemical that one applied to that one. And the largest industrial applicators. What happens on utility right away, people don't really get it necessarily until they, in their mind, they get it. I'll give you an example. A gentleman that's a friend of mine, a coworker of mine, has his own hives. And he goes, yeah. He goes, well, where do they go to pollinate? He goes, well, and he's all against herbicides. He goes, well, they go to the right-of-way, utility right-of-way down the line. Why did they go to the utility right-of-way? utility right away, we're killing tall growing trees. What we're leaving is grasses and forests and milkweed and all the cover that all pollinators. You see pollinators running off to the dead of the forest to do pollination. They're on the edges of the fields where they have the flowering plants that they want to use as pollinator material. If you were to spray the herbicide directly on the insect, it would have virtually no effect unless you drown them in it.
And that's what I was trying to get across.
Pesticides as a realm have everything under them: insecticides, fungicides, herbicides, rodenticides, and malinicides, the list goes on. They require now that you have a bee box on, it's an actual thing right on the label. This is an insecticide that potentially could harm a bee. There will be a warning on the label now. You will not find a bee box on any herbicide. There's not a direct correlation of a herbicide causing any ill effect to a bee unless you drown them.
And it's for those reasons we said that, you know, their mode of action is more as a growth regulators and other biochemical.
Actions that are in a herbicide are designed to affect the mode of action that exists in a plant. You know, one of the categories of mode of action is a photosynthetic inhibitor. I don't know of any other organism other than a plant that goes through the photosynthetic process. So it's interrupting that process in the plant. Amino acid inhibitors. There's a variety of different modes of actions. That's how it stops that plant's activity and kills that plant. Like Garlon is a phenoxy herbicide or a growth hormone herbicide. What it causes the plant to do is cell divide so quickly that it dies quickly. That's why you see immediate action with triclopyr-based herbicides and foliar treatment. So most of those modes of action do not exist in other organisms, and that's why there's an innate safety of herbicide that not only insects and animals and humans over a lot of the other pesticide realms. Insecticides are the ones you got to be cautious of when you're talking humans, animals, insects, obviously.
And those are the ones that have been targeted,
Because some
been
of those modes of
insecticides.
actions will actually work in a human being very similar to the way they work in an insect. Nerve agents.
Nerve systems and, you know, synapses and all that kind of stuff. Does that clarify that point?
Can I?
Yeah.
So to clarify, then if something is applied to a tree, it goes into the roots, and then if it happens to flower a little bit before it dies, then there shouldn't be anything within the nectar or within the pollen that is going to poison pollinators.
That's correct.
So what about amphibians?
There are herbicides that are designed that you can apply them in water. Rodeo in the back, an aquatic approved glyphosate. There is no surfactant in that jug. So if you go out and try to use that as a foliar spray on any target, you need to add a surfactant to that product. But we have aquatic approved surfactants. I have Aquachem 90 that's designed that if you had the permit and you had the license to do so, you could apply directly to water to surface weeds or Phragmites. Everybody knows Phragmites. Right? I sprayed a bunch of it this year. Rodeo is the #1 product for spraying Phragmites. And so there are products that are specifically okay in water and don't have much effect on any aquatic life or amphibian. Then there's herbicides that actually have labeling to water's edge, but maybe in the water itself, at the right concentration, they could have ill effects on certain aquatic organisms.
So
And that's all on the SDS. It says that what's level water and what's acceptable.
The label.
Well,
Well, the SDS is different.
the SDS will actually spell out some of that too, amphibian toxicology and fish toxicology.
So it's typically the surfactant, not the herbicide itself.
Sometimes it could be the surfactant itself. With Roundup in the past, where there's been issues with aquatic type organisms, it's been the surfactant. And that's why Rodeo or Aquadine or some of the other aquatic food glyphosates, it's not the actual active ingredient. It's not the glyphosate that's causing the issue. It's the surfactant. So then we add an appropriate surfactant for that scenario.
Is that surfactant basically what they call an inert ingredient in the product?
Well, I would say a lot of the inert ingredients in a lot of products could be water. If it's a water-based chemistry, it may be emulsifiers. It could be surfactants. Yes. Some products that have surfactants built into them, yes, it could be the inert ingredient. Yes.
Thanks a lot, Todd. So, unlikely to cause acute effects. We just talked about that. And it's important to remember that, you know, pesticides do degrade. You know, it's not like they stay there and they're there forever. And this is basically a natural process of them breaking down into more simpler, less toxic compounds of carbons and oxygens and so on and so forth. So they can degrade because of action by sunlight, by microbes that exist in the soil and elsewhere, you know, including fungi and algae and so on, as well as just chemical degradation. It's something that occurs. So important to remember that once you put those materials there, they do have a process they go through where they're going to degrade. And that can vary. This is just a couple of examples. Time needed, this half-life, you know. It's not uranium here. So, you know, we're talking for glyphosate, you know, 45 days. Triclopyr, which is Garlon, you know, 46 days. Picloram, which is Tordon, or pathway, right, also. So these are relatively short periods of time. And so within a relatively number of months, these materials are going to be degraded into the soil. So I don't know if you have anything else to add to that. But that's
what I always explain is they degrade into naturally occurring elements. I mean, people say, what do they degrade to? I mean, these are all just hydrogen, oxygen, nitrogen type atoms that are crossed and connected to make a synthetic herbicide.
Anybody who's had biochemistry, you know it's
degrade into naturally occurring
right.
elements.
Okay, so the thing you do need to be concerned about sometimes is, you know, runoff, and many materials really they do attach themselves. Some are known for leaching, like Picloram can be more of a leaching material, but a lot of these are not. And the way you can minimize any of that, of course, is, you know, you don't want to apply before you're going to have 4 inches of rain, you know, or something like that. But most of these materials are fairly stable, I think, for the most part.
Yeah, for runoff, oust will run off, but where we run into oust runoff has been more in our industrial type applications where we might apply directly to the bare ground, the gravel site. Think of like a little farm. For years, oust was a very common component in the bare ground weed control program. So when you put it on a bare ground situation, you get a downpour right after that, you can lose that oust. In a forest setting where you have all kinds of vegetation to hold it in place, the potential for it to run off is very limited. But we still do buffer oust applications with water. The current labeling requires that. They're going back to a less stringent label on oust here. And we're not using it industrial anymore. We have new chemistries and much more stable work.
And just to kind of reinforce what he said, really, I mean, if you're going to use these materials, the best thing you can do is print the label off on a piece of regular paper, because it's very small on the label, and really read the label, because there's so much information on that label that you should become familiar with. So when properly applied, first, herbicides do not persist very long or move very far, and they're applied at very low rates, okay? We talked about that. Many times only one time in the rotation of a forest. Now with the more impact on invasive species, I think there's actually been maybe more entries into stands than perhaps there were in the past. But the point is, it's relatively infrequent. They're very low in acute toxicity, which we talked about, the LD50, extremely high, which is good. The lower the number, the more toxic it is. And chronic toxicity is harder to measure, but there's really no indication that these really have chronic problems for the reasons that we talked about. And they're unlikely to cause acute effects to wildlife that consume plants. They're eliminated from the body in short periods of time. They're biodegradable with relatively short half-lives and degraded by microbes. And they pose, you know, negligible human health risks. So basically, I always use the word judicious use of herbicides. So, you know, you limit the treatment area. That's one way that you minimize the impacts. You use the lowest dose possible to do the job. And some of that's going to come from experimentation as well. Find out, you know, after you use some of these materials. Even though we can minimize the impacts, we still want to be careful. And in Maryland, to get a pesticide certification, which again is if you're doing something beyond your own even on your own property, I mean, I recommend getting a private herbicide applicator's license because it's good information they go over. And it's been a while since I got my license. I'm not sure. I know our extension office many times provides that material, but you go directly to the Maryland Department of Agriculture. Who here's gotten a pesticide certification recently? Where did you do it online or?
No, I did it through the extension office over.
Okay, yeah, I think they'll usually provide the information you need. Okay, and then there's commercial and public agency applicators, and most of these, professional licenses require continuing education credits, which you heard me mention. So you have to get a certain number of credits every year to maintain that certification. And then this is just a disclaimer. But again, thanks a lot. I appreciate Todd being here because he deals more with these materials, a lot more. So.